Today we're going to be doing 3.1 solutions to find the system of equations. So first off, we know that all three, the blue, black, and green lines mean the same thing. So if I ask, is 2, -1 a solution to y equals 3x minus 7, it will be the same as is 2, -1 on the line y equals 3x minus 7, and those are the same thing. Same as if I plug in 2 for x and -1 for y, will y equal 3x minus 7 be a true statement? So this will all be true. And if we go on the line here, you can see that 2, -1 is on the line and it's true. So we're there to show how this works. So if we take this down here, then -1 equals 3 times 2, -7. Minus 1 equals 6 minus 7. -1 equals 1. And then we find out that's true.
Great, thank you. All right, so now getting more into this specific section, we're talking about a system. We're talking about a system of equations, all right? So in a system of equations, remember a system of equations is two lines, right? So when we are thinking about is 2, -1 a solution to this system of equations, that's the same thing as asking, is this on the first line and is it on the second line, all right? It's only a solution if it falls on both lines. In other words, we're wondering, is this where the lines intersect each other? We could go down to the green statement, and it's the same exact thing as the first thing we did, but we're just saying that if I plug in a 2 for x and a -1 for y for both equations, are they both going to be true statements? And so if you look at the graph that I did on Desmos, you can see that if I graph both of these equations, 2, -1 is exactly where these lines intersect. And so because that's the intersection point of both of these lines, we know that it is, in fact, a solution. All right. If we take both of these equations, let's take y equals 3x minus 7. Now we know from what we did on the first page that if I plug in a -1 for y and a 2 for x, we do get a true statement, right? -1 equals -1, that's true. And if we take the second equation, 2x plus 9y equals -5, and if again we plug in a 2 for x and a -1 for y, we can solve this and simplify, and we get 4 minus 9 equals -5, and that again is a true statement. All right, so when you are asked, is this point a solution to this system of equations, you can do it two different ways, right? You can see if this is where they intersect, or you can plug in the x and y values and see if both are true statements, all right? If only one is a true statement, or if neither are true statements, then it would not be a solution because that's not where they intersect. So this example here, I would recommend maybe you pause the video and try this on your own. All right, so if you tried this problem, you should have found out that this is not a solution. So if I take my first equation, y equals 3x plus 15, and if I plug in a -3 for x and a 6 for y, we'll get 6 equals 3 times -3 plus 15. So that means that 6 equals -9 plus 15. And if we reduce that right side, we do get 6 equals 6, which is true. So far it's looking like it might be a solution because it is on this first line. But now we want to see if it's also on the second line, if it's where they intersect. So if I take my 2x minus 4y equals 1, and I replace the x with a -3, and if I replace the y with a 6, we can reduce this and get -6 minus 24 equals 1. And we know that -30 does not equal 1, so that's a false statement. So because we get a true statement and a false statement, all it takes is one false statement, and we would say that no, this is not a solution, right? It's not where these two lines intersect. So just to wrap it all up, we want to think in general, how many solutions can a system of linear equations have, right? On this page, we saw that there is one solution, right? 2, -1. And even for this system, we didn't find that -3, 6 was a solution, but maybe there are more than one solution, or just one solution, or maybe there are no solutions. So the way that we figure this out is by thinking about how can we have lines intersect? We know that in one way, we can just draw two separate lines, and they can intersect in any way, right? It doesn't matter if they're perpendicular or maybe they intersect at a certain angle, but in this case, they intersect at exactly 1 point, all right? So if you have intersecting lines, all right, these have exactly 1 solution, all right? So intersecting lines have 1 solution. Notice they have different slopes. All right, so if you have 2 lines with different slopes, you know that there will be 1 solution. Another way we could draw 2 lines in the coordinate plane is if we draw 2 lines that are parallel to each other. All right, so you remember from geometry that we draw these little arrows on the lines to show that they're parallel. So if I have parallel lines, we know that there are actually going to be no solutions, all right? There's no solutions because these lines never intersect, all right? So there's no point that they both have in common, all right? If I'm talking about parallel lines, we know that they have the same slope and they have different y-intercepts, all right? So if you have 2 lines with the same slope but different y-intercepts, you know that they're parallel, and therefore there are no solutions to this system of equations. And then the other thing that we could have happen is if we actually have the same line basically on top of itself. So use a different color here. If we have the black and the red line are actually the same line, they might be written differently, like one might be written in standard form, one might be written in slope-intercept form. But if you have the same line that falls on top of itself, we are going to get infinite solutions, all right? So if you have the same line, you would get infinite solutions. All right, you could also write all real numbers for that solution. And this would happen when you have the same slope and the same y-intercept. All right, again, you'd probably see these written differently, like one in standard form and one in slope-intercept form. You might have to rearrange some things, but there are 3 possibilities, all right, in general, because there can't be 2 solutions, right? You can't have a line and then have a second line that somehow intersects twice, right? You could have that with like a parabola and a line, but there's no way you could draw 2 lines and have them intersect twice. You can only have 2 lines intersect 1 time if they're just intersecting lines with different slopes. They could have no solutions if they're parallel lines, or they could have infinite solutions if they're the same line, all right? So there's only 3 different ways that we can have these lines intersecting, either 1 solution, no solution, or infinite solution.